as we become more familiar with the product rule, we can see that it gets extended further and further. Here's an example where we have the trig, and we actually have two cases where we have a product. This could be considered a U times a V, and then you could start all over. Here's another UV. And so I'm going to walk through this. I don't actually use the U and V on these because, like I said, you should be getting a little bit more comfortable with it. And then part two, it would become a little confusing to have this is U and that is U. So when it becomes more complex, we just run through it. We understand the process, the procedure. And so as I look at the derivative, this is displacement, so this would be my velocity. I'm going to do U dV, so 5t squared. Derivative of tangent is secant squared, plus V, tangent t, du, the derivative of 5t squared is 10t. And then essentially we start all over again. So I'm going to cover that up and start all over. uv, so u is 3t, derivative of secant is secant tangent, plus v du. Well, v is going to be secant tangent, and du, notice that I went with a sign too. You got to take all of that. Derivative of this is -3. And then my next step is to just combine what I have, look at what I have, and see if I can do any simplification. Notice that I went from the s prime t to vt because that's a velocity function. I was able to pull out 5t from both parts here. And so as I pull a 5t out, actually this is just from the first part. I pull 5t out. This would leave me with t secant squared t plus 2 tangent t. And then from the second part, I was able to pull out a -3 secant t. As I pulled out -3 secant t, it left me with t tangent t plus 1. And then from there, there really wasn't anything else I could do. So at that point, I just kind of left what I had. There could have been other things, maybe looking at the tangent t's, you could have pulled those out. It wasn't really going to get me anywhere. And so one of the things that you want to look at when you do derivatives is being able to look at equivalent statements, particularly with trig functions. You know, trig functions can be rerouted. You can work 10 different ways. I like to call it circular arguments. You know, sometimes you're working with a trig function. You can go in a giant circle, have 10 lines of work, and get back to where you were 10 lines previously. So you really have to be careful with those. I'm okay with this one for an answer here. I didn't really have any end game in mind. And so here we showed the u, v, where it was applied twice within one function, and we came up with an answer.